Hi everyone, my name is Benedek Horváth, and today with my colleague Bastian Kruck, we would like to present you how we are using Modelix in a product and how we are going to continue using it with the new features. So the product we are going to talk about is Itemis Secure. Then we are going to show a problem that our customers are actually facing and how we are using and we use Modelix to tackle this problem, and then a short demo afterwards. So Itemis Secure is a market-leading tool for threat analysis and risk assessment for the ISO 21434 certification. It's a product built on MPS. It heavily uses a lot of features. And for example, from the domain perspective, you can do threat and system modeling. You can model your damage scenarios in the cards. You can do impact analysis, risk assessment, and then also this attack tree analysis, which describes how feasible an attack is and what mitigation measures you implemented in your system to mitigate these risks. And from Itemis Secure, we built a web application of a small part of this MPS product, which is the threat catalog. This threat catalog is published and is available at the ASRG Garage. ASRG stands for the Automotive Security Research Group, and it has many OEMs, many customers, and also many people working in these companies. And basically, with threat catalog, you can model your threat classes. So these highest level threat classes and also have some hierarchy. You can do some feasibility ratings according to different dimensions. And then you can also export all these data from the threat catalog to the OpenXM open source data exchange format, and the catalog is deployed at the ASRG garage, and you can try it out. And actually, the catalog collects all the threat classes that you will use in your threat analysis and risk assessment scenarios. So, for example, if you do a Terra for your headlights in the car, or for the brakes, or for the infotainment, then you collect all the threat classes in this catalog, and during the Terra, you instantiate these threat classes as threats, and you can use these threats in the damage scenarios and also all these calculations. And I have a question to our domain expert, Basti, that could you tell us, please, how you are using Secure and how you are managing all these terras at the moment?
Yes. So let's imagine I'm a security expert and doing these security analyses, and we do like hundreds of these Terra things, right? So an issue that we have there is that we now need to manage these Terra projects, which many people are creating, and we have a separate thing, this catalog thing, which is also like a repository, and we do need to do like Git 2 times, and sometimes we need to be aware of keeping them in like the right catalog version there. We tried also Git submodules, and I mean, we're domain experts, so Git submodules are also already hard for you software engineers, as I heard. So for us, that's not really a useful thing. But I heard there's some other ways to go.
What if I tell you that we have a better solution or better way to go than
Wow.
just using Git to store your model? So actually, uh, our goals are to have, so we have the MPS product, and also we have this web application. So one of the big problems is how do we share the data and how do we let our customers to use MPS and or the web application at the same time to have the same data available. This second goal that we have is in the web application, we would like to allow live collaboration for the customers so that they can do their taras more efficiently, quicker, have better teamwork, and so on and so forth. And the third one is we would like to have the great benefit of Git, which is the version control, and to be able to have different versions of the Terra so that the customers can see what changed and why they make those changes, to do rollbacks or all the things that you can do with Git, but without actually using Git. So like we mentioned, all the customers are using Git to store their models with the classical operation: pull, commit, push, resolve merge conflicts in MPS, and so on and so forth. And the challenge is, with Git, you have no out-of-the-box support for live collaboration, and Git is, as Basti mentioned, is difficult for our domain experts who are doing the Terra analysis to use, and also from the developer perspective, it's a bit difficult to use in a web application. So it's a bit difficult to use Git as a model database in a web application. And that's why Modelix comes as a rescue, because the idea is that Modelix is used and can be used as a model database to store the data, and it also has some support for live collaboration so that the multiple users can edit the same model parallel in the web application, and they can see all these changes and so on and so forth. Of course, there might be some conflicts between the changes. So, for example, if one person is changing an attribute, the other person is deleting this thread class, then we will have a conflict that we will have to resolve in the browser if they are using the web application or in MPS. Yeah, we would like to have the dependency just like in Gradle, so we can say, okay, which Modelix server to use, the versions with incremental updates, and also to have multiple catalogs in the Terra, and to be able to use these catalogs seamlessly and flexibly. Yeah, the benefits that we expect from this development is we will use Modelix as model database instead of Git that stores the files as a file share. So we would have better data transfer between web and desktop. The second benefit will be the live collaboration in the browser with eventual consistency. We would keep this version control just like in Git, and we will get rid of Git, which will be beneficial for the customers as well. And as in the Modelix talk, it was mentioned, with Modelix, you can generate TypeScript or Kotlin classes from your meta model, so you can reuse the same concepts. You definitely find them only in MPS, but then you can use it in the Modelix applications. And last but not least, we have in-house support for Modelix. There are some trade-offs. First of all, we have some software engineering terms that are still used or will be used by the domain users. For example, we have change requests, which are like branches in Git. We have versions which correspond to tags in Git. We have this merge and reject to merge the changes or reject the change request. And like I mentioned, merge conflicts may also emerge because they are difficult to avoid sometimes. And now we will show you a short demo.
Okay.
Oops, sorry.
Yeah. So I'm still the domain expert, right? And what we see here now is we're looking at the catalog. So this is the place where I can be managing my thread classes that we are using in all our specific analysis projects. They all depend on can depend on this catalog now. And well, we can try to make some change here. Like maybe there's a specific thread of spoofing the location from Munich. And maybe that's better. Would be my. I think you folks call this the commit message, but yeah, for us it is like now the change request name that is being created. And we can now, like, this is how I'm following a workflow that is a bit alike like a Gitflow one, where you also do change requests and you have some maintainers. So I now was submitting a contribution to the catalog. And there are some other maintainer people which will be able to review those. So stepping in the shoes of the maintainer, we can see that there's a change request and what they changed. And this is a specific thing where we are actually going more specifically into the workflow of our domain than what you would typically do when you do with Git. Because in here we are immediately creating a version branch out of like after we merged this specific change request. So we don't have a develop or a trunk or so. We can still decide for what size of a change this was. So if we are like which digit we are incrementing in our semantic version. So maybe that was rather a bug fix. And now that I merged it, we can see that, okay, the thread class was updated. And this was already, we're already looking at this updated version, and we can go back. So before that, for testing, I added a space in the end here. So these are what you folks call branches, what we now call versions. And also if I create a new change request, we have a branch, what you call branches for each change request, right? So maybe, well, let me start from the last one. No, I broke it. So if I create another change request here, we can see that this is just another branch. And that's very useful for us to be modeling this in the web in our domain-specific workflow. And that's sort of the first half of this everything, right? To have the data over there in a format that is actually, we like, just that you get an impression, this is the tool we use on the everyday base. And for now, it's fine for us to still do the Git stuff in here, just for our own repository of the specific Terra analysis. And these thread classes could up next be consumed from that model server. So these, I wanted to show you, like, this is indeed the database schema of the, well, over there, that is the database schema of the model server that we're running behind that. And if we look one bit more closer inside into this, we can see how we are naming our branches, maybe like how some of you are used to calling your Git tags or Git branches. Yeah. So that's what I wanted to show.
Actually, that's also what we wanted to show, some attributions to the figures. And yeah, thank you for your attention, and let us know if you have any questions.
Yeah. And we are hiring.
What database did you use to store your model part?
That's the key point. We use the model server from Modelix. Yes.
Okay. And what led you to not to use the Git and make some encapsulation for the user?
Because since we store it in Modelix, we can use it as a web database, but we can also use it as the persistent, like the storage for our MPS models. We didn't show this right now because we don't have it implemented and ready for demoing. But as we saw in the demo from the Modelix folks, they can sort of replace storing the models locally and commit them to Git. They already implemented to instead load these models from the model server. And that's why we did this, so that we can actually be editing this with our domain-specific workflows and still be using the MPS to load these models into it and get all the nice references and have the the Gradle-like or Maven-like dependency kind of things. So that's nice user experience and still hopefully easy to implement on the MPS side.
Thank you.
Does that make sense?
Yeah.
It's not so much a question, it's actually a bit of a reply to the previous question. In all attempts I've seen to put a simplified layer on top of Git, it breaks. It mostly breaks very soon, and it latest breaks if there is some conflict resolution. I have not seen any working abstraction over this, which should be easier to the user. So you're always getting down to some Git wizard doing their stuff in all the experiences I've seen.
Any other question? First, any question from this side?
I actually have an answer on the question before that or something. But it's about merging. But what I see is a kind of pattern reoccurring because I'm an old guy in terms of switching from parallel development to a central database and then come back to the conclusion that we actually want to work in parallel. So we have to merge. But at the same time, we want to make it easy. And I think the only solution is that you make a solution specific to your DSL, which makes it easy to merge. So in general, I agree with the remark that was just made before me, but if your specific DSL restricts you from making certain changes or has a certain semantics and syntax which does not, or in a controllable manner at least, create merge conflicts, then you can solve the issue on DSL level. So not in general, like in MPS or like in Git, but for your specific DSL. So I think it's definitely possible. I don't know if you recognize this answer in your specific case.
So you mean like it's about conflict resolving now, so that if with our domain knowledge and our tool crafting, we can build it so that we are avoiding conflicts?
Yes. Yeah. So you or make it at least manageable and understandable for your specific DSL user within the domain.
Yeah.
Specific to the domain. So create a specific solution for merging for your domain instead of a generic one. And that's definitely possible, but it's part of your DSL design.
Yeah.
To enable that.
So, I mean, what comes to my mind there is our thoughts about the semantic versioning. And we picked this intentionally so that we would have some, so we're still assessing if all users like that. But the idea of us being opinionated about the versioning scheme would allow us to maybe do, like a update of the rating of the feasibility for a thread class. Maybe is a minor, like, or a patch, like the last digit kind of change, so that this kind of automatic updating, using these wildcard patterns would actually be a domain specific thing that they can make use of, because what means backwards compatible in our domain with its thread catalogs is something that we can indeed think about and specialize for that.
Yep.
So yeah, that's maybe an example. It's not exactly avoiding conflicts, but something where we can specialize.
It makes the conflict manageable within the context of your specific domain.
Yeah. But I guess Markus also wanted to answer on that.
Yeah, just to confirm, I think what you were saying is, for example, using locking at a granularity that is aligned with roles and processes in the organization, so that,
for example.
Yeah. Okay. Yeah.
It's specific for your domain.
Yeah. Exactly. Yes. Yep.
Any more questions?
More a question about this particular application rather than MPS. But does threat analysis equate to like risk analysis in the financial services domain? I mean, your applications or examples were from vehicle manufacturers, but is it also applied in, say, for, when you're doing, I mean, in the company that I work for, we have a very large risk organization who looks at the risks of contracts, the risks of audits. Do these techniques get used in those domains?
Yeah. So we are sort of specialized to the automotive domain because there are some specialties to it. One specialty in general about these risk assessments, about what we called Terra here, is that when you do traditional risk, like thinking about risks, you have something like a probability multiplied with impact. And probability for the safety people and for some other kinds of risk assessment typically is like a chance, like 1 out of 10 times or so. When it comes to security, it's hard to say like 1 out of 10 hackers will do that. That's really like a weird thing to think about. So the feasibility rating and the way how we come up with feasibilities is what much different. That makes this a bit like specific to, like that makes what is called terrors there a very different thing from the HARAS that existed before, the hazard like analysis and risk assessment. And our thoughts about like the sidestepping to IT security, not like this thinking about components of a car or so. So there are some thoughts about that, but still also IT security tends to think about different things because typically it's it's not that often that someone dies when you have a 0 day, which is in vehicles like a common worst case scenario. So they put a different kind of efforts in there. The workflows are different, and also the way how they come up with their attack paths differs.
So no.
Any more questions? Yes, no? So